Guys, hope all of us are doing great. Today we're going to look at the concept of a differentiation of a trigonometric function. And basically in this short video, we're going to do the sec over x. Now from various representations of trigonometric ratios, we see that basically we have three basic trigonometric ratios. And they're inverses which form a set of a sec, cosec, and a cot over x, or a cot over function. So in this case, we're going to look at the concept of the derivative of a sec. And we are going to represent this one in terms of d over dx, the sec x given in this specific case. So in this particular case, we are going to use the concept that basically this is an inverse of a function, and we can equate this one to d over dx given as 1 over the cosine over x, as I mentioned. Of course, this is going to form the inverse of a basic function, which is the cosine of x. And in this particular case, we're going to employ the concept of a reciprocal rule. And this rule is going to be, of course, assisting us to find the product of this basic trigonometric, or rather the inverse of a basic trigonometric function of the cosine. Therefore, from our last discussion, I mentioned that if we have a function x, or rather if we have a function g that is differentiable, I mentioned that if we have a function g is differentiable at x, and whereby g of x is not equivalent to 0, and then we are going to have another specific function, or this specific function is represented as 1 over g is differentiable at x, and the derivative is going to be represented using this specific representation of 1 over g prime over x is given as negative 1 over gx the square of g, and then x prime given as such. So this basically is a theorem that states that if a function g is differentiable at x and g of x is not equivalent to 0, then 1 over g of x is differentiable at x, and the product, or the first derivative 1 over g prime x is given as 1 over the square of g prime of x given as such. So if you look at our specific representation for this trigonometric function, is going to appear in terms of a reciprocal, and therefore we're going to employ the concept of a reciprocal rule in trying to solve or find the answer to this particular problem. So therefore I'm going to represent this in this specific order, whereby we have said that if we have this particular function as 1 over the cosine, then therefore the d over dx over 1 over the cosine x can be given in terms of negative 1 over, so our function is going to be, the g of x is representing this particular function of the cosine, and therefore gx implies the square of the cosine of x given as such. So therefore we're going to have the square of gx represented by the square of the cosine of x, and then we're going to have this one gx prime, which is representing the derivative of this particular function of the cosine, which basically is negative the sine of x given as such. So this basically is going to give us the answer that we are going to find for the derivative of the sec. And basically we have employed the concept of this particular reciprocal rule in finding this specific product. So this basically gives us, so the negative sign, and this one is going to give us the positive, the sine over x, all over the square over the cosine of x. So this can as well be given in terms of the sine over x all over the cosine over x times 1 over the cosine over x. So I've just split the denominator to appear in this particular form. And from our representation, we have said that basically the concept of the sine over x over cos of x represents the tangent over x. So the answer is appearing in terms of the tangent over x, and then we're going to have the inverse over the cosine over x represent the sec over x in this specific order. So therefore we can give this answer in terms of sec x tan x as the derivative of this particular function over the d over dx over sec x in that specific respect. So as we are seeing from this, we're going to employ various strategies, especially by borrowing from the reciprocal rule in order to find the differentiation of a trigonometric function that goes by this specific name of sec over x, which I said basically is the ratio between or the inverse of a basic function of the cosine over x given as such. So in our next discussion, we're going to look at perhaps a problem set that is going to assist us understand in terms of a problem set, which is going to, of course, shed some more light on how we can apply this specific strategy in finding, of course, values for differentiables or the derivatives of a trigonometric function. So that is it for now, guys. By God bless you. Catch us in our next video.